Thank you for that great introduction, Bruce. So this is me. I'm Rebecca. This is me at my day job, detecting JavaScript bugs. I'm a front-end engineer and team lead, and that means a lot of different things at different companies, so I'll explain what that means for me. And that is that I mostly write JavaScript, some HTML and CSS, a lot of React. I also am responsible for the delivery of a team of about 8 people, and I manage the 6 designers and developers in that team. So there's a lot of work going on there. This is also me. About 4 years ago, I was part of a program that we were running in New Zealand, which is where I'm from. Yes, Lithuania is a very far way away from home. And so the idea here was that we would get young women from schools around New Zealand to come into software development companies and learn a little bit about what it was like being a software developer. So they were about 14 years old, and they were all in the same tech class at school. And I could go into a big old tangent here about women in tech and how depressing it was when many of them said, oh, next year, I'm not going to do my tech class because it's not cool for girls to do anymore. And how rewarding it was at the end of our program when they were like, oh, this shit is awesome. But anyway, what I wanted to focus on was the story about how these young women and a lot of other young developers were really the inspiration for this talk. Because having worked with junior devs quite a lot, I'm extremely passionate about it. And one of the things that they've really struggled with was figuring out how to debug. So for this talk, I tried to take a step back and think about how I actually debug and what the difference in technique is between what I do and what they do. So hopefully there's something useful in here, no matter how deep down this rabbit hole you've been before. But I really want to hear your thoughts also, so feel free to tweet at me. I'm at Rebecca. So first of all, I want to take a look at the psychology. How often have you actually stepped back and spent time to think about how you debug? It's easy to forget that it's a difficult skill to be mastered. It's learned over time and improved with experience. This becomes particularly clear when we compare those junior developers and more experienced ones. Often newer ones jump straight into debugging, making changes to the code everywhere in the hopes that something will work, something will stick. And then they don't know what they've changed, and they can't figure out if the bug's actually fixed and what actually fixed it, and they get very confused. But it's something that we do pretty much every single day. So this talk was born out of a question. How can we improve those fundamental skills? So let's do that. Let's take a minute to think about how we do it right now. So maybe we have some good habits that we can try and do more often, and some bad ones that we can forget. Let's start at the beginning. So I guess most of you will probably know by now is the beginning is reproducing the problem, right? And if it's not an easy fix or a typo or something maybe shown by the console error, then what I try and do is write a test that reproduces that bug. It's nice to keep you focused on just that one thing. It also can speed you up because you don't have to click through the app to try and reproduce the bug every time you make a change. And finally, it'll help you stop your bug from ever returning. Sometimes, however, bugs can be so elusive or widespread that this is not really possible until you've delved into it a bit further. So it sounds obvious, but I think even the most experienced developers out there have times when they've jumped straight in and changed a bunch of things before stepping back in frustration. So my personal approach is I do let myself give that first guess a go, just the first one, because occasionally, especially if you have experience and you know your code well, that first guess works out, which is great, right? But if not, then as soon as that next thought pops into my head, or I realize that the first solution I'm trying is going to be really involved and long, then I take my learnings, revert my changes, and step back to consider my options. This is important because by being disciplined and thinking more broadly about our problems first, you're more likely to consider other possibilities and avoid making a fool of yourself by just realizing that you have the wrong code or that you're on the wrong environment. Essentially, this is all a version of the scientific method. We're doing a similar thing as a science experiment when we debug. By reproducing the bug and hopefully writing a test for it, we are in a way creating a problem statement. We come up with a testable hypothesis, a possible reason for the bug. We test that hypothesis, we observe the results, and we refine. And if there's still no result, then we choose another hypothesis, and so on, until we have a fix or a proven theory for the bug. And once you have that hypothesis about which part of your code base might be causing the bug, the next step is narrowing it down and eliminating all the other possibilities. Often, you can just check that the variables that are as expected when you go through your code base until you find that they're not. And sometimes, if it's something more complicated, I first find something that actually works. I start with a small piece of code that demonstrates the core task that I'm trying to achieve and comment out everything else. And then I re-add the code bit by bit, testing at each point for errors. The same method is useful if you've dived into the code too early and changed too many things. A quick git stash and git reset gets us back to the last working version. And then you can add your changes again bit by bit, testing as you go. In general, though, learn to embrace your bugs. This is how we grow as developers. Try to avoid having a fixed mindset. This is when you view intelligence as a fixed resource, meaning that sometimes solutions are just outside of your ability. If you're trying to fix a bug that you don't think you have the intelligence to fix, well, then it wouldn't be surprising if you get easily stressed, give up really quickly, and maybe start to blame others or other things. Whereas someone with a growth mindset is more likely to collaborate, be honest, have a strong desire to learn, and in the end, be more likely to fix the bug. It's easy to scoff and assume that we're always in that second bucket. But what about the idea of the 10x engineer? How often have you heard that? Someone who is naturally, at an order of magnitude, better than everybody else. And how often have you heard or even said, I'm just not good at CSS, or I'm just a little slower than other developers? It's so easy to internalize that feeling that if something is hard for you, then you must not be good at it and never will be. But being aware of it is the first step to changing it. So learn something from your bugs, improve your process, and celebrate the wins. So let's look at the console. Here we have the polls, they are in. On the left hand, we have JavaScript daily, and we've got 56% of developers here saying they use console.log to debug their JavaScript. And in the other side here, we've got Chris Hellman, and we've got another 67% of developers using console.log. I'm going to take these with a grain of salt. They're not exactly scientific. But I think it is a safe assumption that the majority of web developers use console.log the majority of the time. And it's understandable. We've been conditioned over years to use simple text editors like Sublime Text and Notepad. And a large portion of web developers have also simply missed the exposure to a formal debugging process. And the browser console, well, it's a pretty nice way to debug stuff, right? It's easy and it works, so why change it? Well, there is so much more. So even if we just take a closer look at console.log, you'll see that there are ways to optimize it. So here on the top, we have the normal console.log, where we've got pin 1 and pin 2, maybe they're map pins. And then on the bottom here, we have a console.log with the object notation. And this means that very quickly, we can not only get the full context of each variable, and we also get the value. It's really nice, especially when you're logging a lot of stuff in your application. You can also really easily add styling to your logs to help you separate one thing from the other. By including this %C at the beginning of the console log, you can then include a whole bunch of styles in the second parameter here and get very pretty console logs. And sticking to the console, did you know that there are actually a bunch more methods on that object? So I'm going to show you my favorites, but Googling will reveal a hell of a lot more. So for instance, console.table is super useful if you want to inspect an array of objects. Much easier to compare all the different values on these things. Console.group is really useful for when you end up adding so many console.logs in your app that you can't even find the one you just added. Group and group collapsed are super useful for structuring those logs into collapsible groups. Creates less noise in the console for you to analyze. Another useful function you can use in the console is the $selector. It works similarly to the jQuery selector. It's an alias for document.querySelector in the console. If you include a 0 after it, you get the most recently inspected HTML element or JavaScript object. A 1 gets you the second most recently selected one, and etc. up until 4. It's super useful if you want to quickly see which properties and attributes are on a DOM node or JavaScript object. And if you use $, it's the same as document.querySelectorAll. Even better, it returns you a proper array rather than a DOM node list, and so you can actually then do things on that array. Console.trace is nice to see what's calling your buggy functions. So especially if you're working in a new code base, this was very useful for me recently, and you don't know your way around yet. Here I added a console.trace in this handle filter click function, and you can see that it is called by handle click in filter.js. And console.dir is great when you want to inspect a DOM node as a JavaScript object rather than as its markup, which is what console.log returns you. In Node, though, it's even more useful. So as you can see, console.log spits out your array here in black and white. It also only goes 2 levels deep. You've got this geo object here. Like, what is in that? That's not useful at all. If you use console.dir, you can pass in these parameters, colors, true, depth, set to null, and you'll get the whole depth of the objects in that array, and it's all pretty and colored for you. So let's say we've been working with console functions for a while now, and we want to step it up. Let's dive into the dev tools. So by the way, I'm focusing on Chrome because it's what I'm most familiar with, but as others have pointed out today, the Firefox dev tools are also great. Browser dev tools have some really handy features for debugging, namely the DevTools debugger. So the simplest way to activate this in your code is by using the debugger keyword, which I have highlighted here. When the browser hits that keyword, it will pause the execution of your code and allow you to inspect it. So you can see things like the values of your different variables. You can access those local variables in the console. And you can inspect the entire scope of your code. The really important part is that you can actually step through your code. So we're going to step through line by line and inspect what's going on. So one tool that is almost essential when using the debugger is blackboxing. So this lets us prevent the debugger from stepping into certain scripts when we're debugging our code. Here I was debugging a React lifecycle function, and I stepped through into the React DOM library. Well, I can be pretty confident that my bug won't be found in here, so I blackbox the script. This way, next time I step through a function that hits that library, the debugger will simply ignore it and return to my code. You can also include file patterns in the DevTools settings to blackbox entire folders, like node modules, for example. Another useful trick when you're really unfamiliar with a code base is the commands plus \. If you press this shortcut while JavaScript is executing, it will add a breakpoint to the code and stop executing right away. You'll be able to instantly see what's happening right at the time that you press the shortcut. So the DevTools debugger has a crazy amount of features. For instance, here on the left, you can add breakpoints on certain event listeners. So say you wanted to stop the JavaScript executing whenever you clicked, you just tick that little box there. Or when a DOM node is modified, say in this top one here, when the attribute is added or removed to this particular DOM node, then we can also stop the execution. You can even add conditional breakpoints, meaning that your code is only paused when a certain condition is met. This is really useful for when a certain function, say a scroll handler or a React render, is called multiple times, but you only want to stop execution when part of your state has a certain value. So here I'm creating a breakpoint that will only be hit when the length of my mysteries array is more than 0. So on the initial render, when my mysteries API hasn't returned yet, it won't stop. It'll only stop when there's actually something there to inspect. So you can also now add log points in Chrome. So this is essentially a console.log that you don't have to remember to delete from your code. The debugger won't pause on these points, but you'll get the results in the console as you would normally. So another really useful tool when debugging in the DevTools is the snippets option under the sources panel. So here you can save your own code snippets to run in the console. And there are great collections of snippets, like this DevTools snippets website, that have a whole bunch of different snippets that augment the console. So for example, this one's one of my favorites, which is console.save. And so what you can do is type that in the console, and anything you pass to it will be saved and downloaded as a JSON file. So it's really useful if you've got a big JSON object that maybe you want to share with another developer to help you debug. Another useful tool is live expressions. So you can click the eye icon here in the middle, and what it does is it allows you to type something into the console and create a live expression. This pins it to the top of the console, and it updates real time. It can be really useful when something in your code changes quite a lot. So for example, window.width or the scroll position, for example. And what about when you want to actually test some of your bug fixing hypotheses? Well, a really great feature in Chrome is local overrides. So make sure you first enable it in the DevTools settings, and then you can go to the Sources tab and go to Overrides and set them up. And here we can just create a folder on my desktop. I'm going to pick this one and call it test and select it. You then need to give Chrome access to that folder on your hard drive. And then I can go through here in the Reddit source code and decide to add a background color to it. And I'm going to make it purple, because why not? The best part here is if we Command S, it saves it, indicated by the little purple dot, and then on refresh, our changes persist. This is super useful when you're debugging a production website. When you need to fix a bug quickly and you have a reasonably good idea of where it is, you don't need to have your local environment running or even have the original code on the computer you're using. It can be done with just about any computer setup. So what happens if you want to go further and make bigger changes that you not only want to persist on browser refresh, but also persist to your own project on your computer? Well, the DevTools also have a really interesting tool called Workspaces. So here's a little app I made for calculating insulin dosage for diabetics. Note that it is a production app on Heroku, not on my local host. So if I go in here and I click the File System tab and add my project folder that's sitting on my hard drive, and again, give Chrome access to it, I've got my project here in the window, and I can add whatever I want, change whatever I want. Here I'm going to add a console log to say hi, and again, Command S, and it's saved. And now I switch to my actual project in my IDE, and you can see the change has been persisted. And I can also make changes going back the other way. So now I'm going to change it to say hi everyone, and it automatically updates. This is super cool, and a lot of people have actually used this to do their entire development process. I mean, it can be a little flaky, so I wouldn't recommend it for a full-blown IDE, but it can be really useful. It's definitely worth investigating. So, if you like this idea of being able to persist changes on your production system, well, there's one last way I want to show you. This is the concept of proxying your production files to local files on your hard drive. It's similar to Workspaces, but without the DevTools persistence, and with a lot more other features that better support complicated build systems. The simplest one of the easiest ones to get is this Chrome extension called Resource Override. So say you have a version of your application running on localhost. Using this extension, you could proxy the call that your production website is making, so in this case, bundle.js, to instead load your local version of bundle.js, allowing you to change your code and to test it within the larger environment where the bug actually occurred. Applications like Fiddler and Charles Proxy also allow you to do this, but with a lot more features, including the ability to monitor and inspect all the calls that your website makes. I've been on teams that have literally used Charles Proxy for their entire front-end development flow. Many big applications can be tricky to set up locally, and trying to keep up with the back-end architecture and all the APIs that are changing all the time can be tricky. If, however, you have a reliable staging environment, then proxying your front-end files is a nice way to skip that setup entirely. So a lot of the technology that I'm covering either is seriously enhanced by or doesn't work at all without source maps. So a quick refresh. A source map is a file that allows the browser or other technology to map the compiled and compressed code back to its original file. So it's another really important tool that helps with debugging. Minified code is pretty difficult to inspect. On the top, we're inspecting a website without source maps. You can see the whole thing's been squished, all the variables have been mangled. It is pretty not really that readable. And on the bottom, source maps have been set up. It looks really easy to read because, well, it's the actual code that I wrote. So depending on your build process, it can be pretty straightforward to set up. Here's the config for Webpack, and at the top is a way to tell Webpack to use its standard development configuration, which includes source maps by default. If you want more control, you can define it separately. So I've chosen here cheap module eval because I like the balance between speed and support, but your choice will depend on your use case. And then beneath that, we have the config for production. The only thing you really need is the DevTool property, but if you're using uglify.js to minify your code, you'll want to set a source map there to true to make sure that it still works. And when you build your project, you should see your source map file come out with your other JavaScript files with a .map appended to it. So what about deploying source maps to production? Well, I am a big believer in doing this because production bugs are when source maps are at their most useful. The good thing about source maps is that they only get downloaded when the DevTools are opened, so they have no effect on your application or its performance. And if you're really worried about people being able to see your source code unminified, keep in mind that security through obscurity is never a good idea, then there is a pretty straightforward solution. You can indicate in the JavaScript file a source mapping URL. And what that will do is it will point to the source map that has been uploaded to a different location that's only accessible by your team, say an S3 bucket that only your company's VPN can access. So moving on now to performance debugging, I don't have time to fully do it justice. Thankfully, we've had a lot of stuff about performance just now. Very useful for me, because there's just so much you can learn about here, and it's easily another 2 or 3 talks. But I wanted to quickly illustrate that it doesn't have to be as scary as this flame chart can look when you first look into it. So the key is to find your code, the stuff that you recognize. If you click to open the main panel, you'll see all the activity that occurred in the main thread, including the execution of the JavaScript. Usually, a lot of the content here is found in frameworks, but if you scan through the orange sections, you'll be able to find your JavaScript files, which is usually what you're looking for. It's my main.js file. Note that this is a very basic one-page app, so that's why it's so small. You can then zoom in further and find the functions in your app and compare the time that they're taking with each other. Here we can see a call to append child and fetch, which are a lot more familiar. The easiest and most effective way to debug an app's poor performance, however, is, as was just mentioned, by doing a performance audit using Lighthouse. And I'm so glad that this was brought up because this is an amazing tool. It's inside the audits panel in Chrome, and here you can see the results on the same small one-page app I was just looking at. The best bit here is this opportunities section, where there's a whole bunch of resources that you can optimize and specific details on how to do so. And I'm also really glad we've had an amazing talk about accessibility today because the audits panel also allows you to audit other things like accessibility. And so all of that amazing information that we got just before can come into your app, and then you can check it all and get feedback on how you're doing in Lighthouse. If you follow the specific advice, your app will be so much more usable, and in most cases, improve the experience for everyone. When it comes to debugging specific elements for their accessibility, the Elements pane comes in handy with the Accessibility tab. So here you can inspect elements and see which properties are correctly filled out. So in this case, we're inspecting this text input here. This is, again, the Reddit homepage, where we have input type text. You can see that the name property on the right-hand side is search. But this particular input did not have a label on it. Bad. However, this placeholder property has been used for the name. So in this case, the screen reader would read it out correctly. you can see that because this name is filled in, you are, reasonably safe, although screen readers change all the time, so, always test things. But yeah, really, really useful. So the last thing for the dev tools. Did you know you can even debug Node in the dev tools? So you just need to run your Node script with the inspect flag. And BRK, by the way, means to break before the code starts, so that you can then go and add your breakpoints straight away. And then you either click on this green node icon here, or go to Chrome, //inspect, and click on Open Dedicated DevTools for Node. If you like this workflow, you should check out the Node Inspection Manager extension, which manages all your scripts and windows for you. Okay, so let's get to the really good stuff. Integrated debugging in the editor has been around in various forms for ages, but many JavaScript developers are either not aware of it, they think that it's too tricky to set up, or they don't want to change their debugging flow because they don't think it's worth it. Well, I'll let you be the judge, you do you, but do make sure you give it a go first. Because fortunately, we have so many more front-end focused editor options now, some of which include an inbuilt debugger. I'm going to focus on VS Code because it's super fast and light, and it's what I use every day. I promise I'm not trying to sell you anything. That would be stupid because it's free. But there are other IDEs like WebStorm who also include an inbuilt debugger, and the idea is pretty similar. So I'm going to take you through my debugging process and how I set it up with a mini front-end React app that talks to an Express server. I've added a couple of spelling mistakes to simulate a bug that you might be trying to fix. I'm not stupid enough that I actually think these are bugs. I know that the spelling mistakes. I have had feedback on that one before. Anyway, so a typical process for debugging a front-end application might look something like this. So we open the browser and we see we have an error in the console. We go to the editor and we log out what's going on. Back to the browser and we refresh, or maybe a hot module reload. And if we're lucky, we've chosen a variable that helps us determine how to fix the bug. Back to the editor, then make the fix back in the browser. Okay, great, fixed. That's a hell of a lot of guesswork and switching back and forth between IDE and browser. So let's see how we can improve it. VS Code has a bunch of extensions that let you debug tons of different languages in different configurations. The most useful for us is the Debugger for Chrome extension. It's actually framework agnostic. You could be working with Angular, Vue, or whatever you would like. But I'm going to show you the configuration for my app. So first of all, I'm going to go to the Extensions tab and search for the Debugger for Chrome extension and install it. And just quickly reload VS Code and select to add a configuration. And I'm going to pick here the Chrome launch configuration and change the URL to have port 3000 rather than the default there, because that's what Create React App uses. Save that, and then I can press play, and here my app loads. And that was it. Absolutely no other setup or settings. Was that scary? I don't think that was that scary. I think that was fine. The debugging experience is also really nice. So here we have a bug because this page is supposed to have quotes on it. And so what I'm going to do is go and add a breakpoint here and refresh, and you'll see my breakpoint's been hit. And now I can hover over the variables in my IDE and see, oh, quot here is undefined. I wonder why. And then on the left here, I can see my state, my mysteries array, and see, oh, it's actually spelled quote with an E. Okay, all right, I will fix that. And save it. And remove my breakpoint, refresh, and ta-da, fixed. Yeah, so obviously this is pretty fake, but you get the idea. Yeah, without even touching the browser, the whole thing was fixed. I didn't even have to leave my IDE. So a similar situation occurs with Node. A typical workflow if we're dealing with a Node API might be something like we start with an error in the terminal, and then we switch to the editor, and again, we maybe log some variables out to try and figure out what on earth is going on. And then we might go to Postman to test our API. and go back to the terminal, and then back to the editor and fix the bug. So again, we can really clean up this workflow by doing so much more in the editor. Here's how to set it up. So I've got a bug here, and my API is returning a server error. Not great. And so I'm going to go into my IDE. Sorry, the video's gone small again, but I'm going to add a configuration, and this time I'm going to pick Node Launch Program. So now I'm going to select that configuration and press play. So here I'm going to use curl to ping my API, and you can see that it's returned Pong. Oh, great. OK, API is good. So once we have that debugger running, we can hit this broken mysteries endpoint with our React application and easily debug what's going on in our Node API. So now we can add a breakpoint here to the mysteries array. And we can inspect the request here and see the base URL is mysteries. OK, cool. And here we appear to be reaching an error and says misdes is not defined. Again, I wonder why. So we're going to come back in here and fix the typo, remove the breakpoint, refresh, and then refresh our browser, and everything's fixed. Amazing. Again, so much easier doing everything in the IDE. What's even cooler is that VS Code will allow you to make compound configurations, meaning you can even debug your front and back end at the same time over multiple and different languages and frameworks. So before I finish, I should just quickly mention that in no way have I covered this space. I've obviously had to focus on one browser and one IDE, and I didn't even touch on mobile and network and service debugging, to name a few. There's just so much more to explore here. And of course, accurate and realistic test coverage, and even TDD, are extremely important and useful ways to prevent bugs in the first place. Provide a quick and easy way to test fixes and prevent bugs from occurring again. The golden rule is, whenever you find a bug, make a test for it. So the last thing I want to leave you with is this. If you're going to still use console.log, please at least create a snippet in your editor so you don't have to type it over and over and over and over again. All right, that's it. Thank you very much.